So we've taken a look at how to compute combinations and permutations by hand, by calculator, and how to list them all out. So in this video, what we're going to do is we're going to start taking a look at some applied problems of combinations and permutations. For all of the problems that we're going to be doing, it's going to be strictly combinations. Reason being is because generally combinations are more applicable when we start talking about random objects, and we're going to say they're indistinguishable from one another, and I'll talk about what that means in a moment. So a scenario that we can use that's a pretty basic example to start with. Let's say for some reason we have a box of marbles, and there's 7 green, 11 red, and we're asked to pick 5 of them at random. Notice that we have our bag. All right, so let's just kind of draw this, and we have red marbles, and then we have so we have red and we have green. So now we have 7 green marbles. So I'm just going to say 1, 2, 3, 4, 5, 6, 7. So let's just assume that those are the different marbles, but they're really indistinguishable because they're all green. And then we have red marbles, and there's 11 of them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. All right, so that's what's in our box. All right, and just assume that the numbers represent the marbles for us. It doesn't really matter whether we select which number of green or which number of red. They're all going to look the same no matter what. All right, so I could have just used dots if I wanted to. All right, so let's just go through and maybe answer some of these questions now that we've had a little bit of background as to what we're looking at. Oh, so since they're indistinguishable, in other words, green is green and red is red, and we can't really tell the difference between the marbles aren't necessarily named. I just put numbers in there. How many different ways can we select the marbles? All right, so we know that there's a total of 18 marbles. All right, so we could just add these together because that's going to be our 7 plus 11 is going to be 18. We also know that we're selecting 5 of them. So for letter A, the number of ways that we can select the marbles is going to be 18 combination 5. Right? And we're just going to go in our calculator, just like we did in the previous video. We're going to type in 18. We're going to go to math. We're going to go over to probability. We're going to select NCR, and we're going to select 5. And 8568 is going to be the answer. Right. How many ways can we pick 3 green and 2 red marbles? So we have this keyword and. All right, and we probably remember that and represents multiplication. All right, so we're going to do that. Now, 3 green marbles. All right, so we want 3 green. Well, notice that there are a total of 7 green marbles, right? So there's 7 green, and we want 3. So we're going to have 7, 3, and then there's 2 red marbles and 11 total that we're out of selecting. So we have 11 combination 2, and remember, we're going to multiply these numbers together once we get them. All right? So if we start divvying them up into the different colors, that's when we're going to have to start using the individual sorts of properties for those. And this one we use 7 and 3. All right, so we're going to go in our calculator. We're going to say 7 math probability 3 for combination, and we get 35. And then we have 11, 2. So we're going to type in 11 math combination 2. Hit enter. Hit enter too quick. I forgot to put the 2 in there. So enter, and then 2, and then enter. And we get 55, and we can just take 35 times 55. 1925. I think that's the year I was born. So remember, we got 55 and 35, so this becomes 35 times 55, which was 1925. So hopefully that makes sense. Another example, letter C. How many ways can no red marbles be selected? So now this one, no red marbles. All right, so if we're picking the red, we know that there's 11 red marbles, and we want none of them. So we know right away that we're going to have 11, 0. But at the same time, doesn't that also implicitly mean that since we're picking 5 marbles, that all 5 of them have to be green? So even though it doesn't say that there's 5 green marbles, we are also going to have to pick 7, 5. All right, again, that's just because there's 5 total marbles that we're selecting. If we're not selecting red, then we have to select all 5 of them to be green. So let's go into our calculator. We have 7, 5. So we have 7, oh, not 77. So we have 7 math combination 5, and that's 21. And we're going to have 11 combination 0. Now this is going to be 1. Anytime that second number is 0, there's only one way to pick no red marbles. You pick no red marbles. All right, so that just makes sense. So we're going to go back here, and we're going to say 21 times 1. And if you want to verify that this is 21 in your calculator because you don't trust me, it's certainly fine. All right. Now, the last two are a little bit sneaky. These are at least problems. So letter D, we want at least 3 green marbles. All right, so now what does that mean at least? Well, that means a minimum of 3. So the different scenarios are we could have 3 green, we could have 4 green, we could have 5 green marbles. We can't have any more than 5 green marbles because remember the top number we can pick is 5, right? So whenever you have these at least problems, what you're going to do is you're going to start with the number and you're going to go up to the max, right? So that way you can go through and you can find out what that means. Now we still have to figure this out, all right? But it's not too difficult at this point because, well, remember to get 3 green, remember we have 7, 3, but we can't forget that implicitly that also means because we're selecting 5 total that we have 11, 2. All right, so we have to be careful with that. We can't forget about the other one or the other set. So there's 4 green, we want 1 red, and 5 green. There are 0 red. All right, they have to happen at the same time. So this is going to be 7, 4, 11, 1, and then 7, 5, 11, 0. All right, now this looks like it's bad news, but the good news is 7, 3, 11, 2. Oh, we just did that up here. All right, so that's helpful. We can just recycle these values. So remember 7, 3 was 35, and 11, 2 was going to be 55. This one we don't know yet, but that's okay. And then 7, 5, 11, 0 is right here. All right, we just computed that. All right, so we're just recycling some of the answers. And then we're going to have to do the one in the middle, so that's not a big deal. So we're going to do 7, 4. So 7 math 4 is 35, and then 11 math 1. It's going to be 11. And another trick is that if the second number is 0, you get 1. If the second number is 1, you always get whatever the first number is in a combination. So that's going to be 11. So we get 35 times 11, which I think is 365 or 385. Let me check. So it's 385. All right. And we need that number for later anyway, so we'll just hold on to that. So we have 35 and we have 11. All right. So we know that 35 times 55 was 1925. We know 21 times 1 is 21. And then we just got 385 right here. All right. And I got the 1925 from right here and the 21 here. And the question is, what do we do with all these numbers? Do we multiply them, subtract them, divide them, whatever? Well, because these are disjoint events, meaning that we can't draw 3 green and we can't draw 4 green at the same time, then we're just going to add these together. All right, so we're going to go through and we're going to say 1925 plus 385 plus 21, and that's going to give us 2331. We add those together. So that's going to be equal to 2331. All right. And what I'll do is I'll start the next video to be able to figure out letter E, which is how many ways can we get at most one red marble. All right, but this might be a good opportunity to maybe think about this, practice it, and then go back to the next video to see what that's going to be.